Okay, let's take a look at this word problem. If you haven't done so already, now would be a good time to pause the recording and attempt it yourself. Otherwise, let's go on with our usual problem-solving steps. The first step is to read the problem. The second step, once you've done that, is to determine whether or not there is an appropriate diagram. Again, this is not a great question for a diagram, so let's move on to step number 3, which is to declare variables. Again, let's actually analyze this problem to see what kind of problem it is before going ahead and declaring variables. We can see that there is a group rate here. So there's a $1,500 group rate. That's, in other words, a $1,500 cost. And there's a price per person. And a certain number of people. So how many is the original question. So we've got a situation where we've got a total cost, which is $1,500. We've got a cost per person, or a price per person, and we've got a number of people. The equation that relates all those together is total cost, or I guess to use the terminology here of the problem, it's the total price equals price per person times number of people. And in our usual fashion, we can actually use that as the top part of our table. This is a good problem to use a table for. So we've got a situation where we've got the original group, and we've got 5 no-shows. Begs the question as to whether or not this is a good model and whether or not people actually put deposits down, but this is a word problem, and so we've simplified it considerably. So what we do know is that there's a $1,500 price tag for the kayak trip, which is the same in either case. And now we can declare a variable. Our variable could either be one of the price per person or the number of people. Since the question asks how many people were originally scheduled for the trip, I'm going to use that as my variable. Then the number of people when 5 have failed to show is going to be x minus 5. The price per person then is going to be the total price in each case divided by the number of people. So 1,500 divided by x in the first case, and 1,500 divided by x minus 5 in the second. And then the question becomes, how do we set up the equation? So I'm just going to scroll down a little tiny bit. I will draw your attention to one little bit of the word problem, which is that the price per person increased by $25 once the 5 people failed to show. So that's going to be our equation relating the price per person in each case and the extra $25. So I'm going to go down a little further and write that the original cost per person equals the new cost per person. That's actually not true. There's an extra $25 in there. And let's figure out where the $25 should go. The original cost per person was a certain amount, and then when 5 people failed to show up, then people had to pay $25 more. So the way to look at that is that the original cost was lower and that the new cost was higher. So we're going to have to add $25 to the lower cost to get the new cost. If you're confused by that, put some numbers in instead and say if the original cost per person was $100, the new cost would have to be higher than that, $125. So what we've done is we've added $25 to the original cost. Okay, so let's write in what the cost per person, or the price per person, is. It's 1,500 over x plus 25 is equal to 1,500 over x minus 5. Now I'm going to scroll down a bit. This would also be a great time to pause this to see whether or not you can solve this one for yourself. Okay, it's a rational expression, an equation with rational expressions. So as always, we can multiply both sides by the lowest common denominator, which in this case is x onto x minus 5. And if you take a look at the very first term on the left-hand side, the x's are going to cancel, so we're going to have 1,500. Let me use blue here. Onto x minus 5, plus 25 onto x times x onto x minus 5 is equal to 1,500x. So now, expanding, we're going to get 1,500. Actually, before we do that, one of the things that I'd like you to consider is the fact that the numbers look pretty large here, but notice that every single term is divisible by 25. And if you need to, then you can just go over to the side and say, what is 1,500 over 25? Well, that's the same as taking out a 5 from top and bottom, and so that's equal to 300 over 5, and then take out another 5, and you get 60. So if we divide both sides by 25 now, we get that 60 onto x minus 5 plus x onto x minus 5 is equal to 60x, and that's going to be a lot easier to solve since the numbers are substantially smaller. So multiplying through, we get 60x minus 300 plus x squared minus 5x equals 60x. Notice how these guys are going to cancel each other, leaving me with x squared minus 5x minus 300 equals 0. Now 300 is a pretty high AC when you don't have a calculator. So this would be a great assignment question, but not such a great quiz question. The previous example I gave you with the pizzas is a much better example of what a quiz question would look like. But let's go ahead and AC it anyway. I'm going to scroll down a bit. If you wanted to pause now, it would be a good time to see if you can actually factor this one yourself. And so I'm just going to write down all of the pairs that multiply to give 300. If you happen to see right off the bat the pair that works, then that's a good thing for you to just go ahead and write. Otherwise, we'll go 1 and 300, 2 and 150, 3 and 100. Notice that the 2 and the 150, I can take a 2 from the 150, so I get 4 and then 75. 5, of course, goes in 60 times. 6 goes in 50 times. 10 and 30, and then 15 and 20, and of course it's this last pair that we want. They're going to have opposite signs, and we want the 20 to have the negative. And again, because the leading coefficient of this guy is equal to 1, we can just go ahead and write that this is equal to x plus 15 onto x minus 20 equals 0. And so the solution to the equation is negative 15 comma positive 20. That, of course, is not the solution to the word problem. Negative 15 people doesn't really work here, so we're simply going to stick with the 20. And remembering what our variables stood for, that means that there were 20 people signed up for the trip originally. Let's take a look and see by a quick check whether or not that makes sense. If there were 20 people, they were paying $75 each. If then only 15 people showed up, they'd pay $100 each. And so the 75 cost would go up to $100. So yes, it did in fact increase by $25. So our check works, and I believe that we're done.